Greg, KO6TH, go ahead.
As we've been having the morning chats and other things I've been mentioning about activities I've been doing outside of ham radios, it turns out, with backyard astronomy. And people have been asking questions, so I thought I'd give a little tour of what this whole thing is about. Looking back, growing up in the space age and stuff, I remember sitting around the TV set, black and white TV set, with cameras with film in them pointed at the TV set, because that was pre-VCR days, taking pictures of the moonwalks and that kind of thing. Neat time to grow up. When a garage sale happened about 20 years ago up here in Auburn, my wife and I picked up a telescope and proceeded to put it in the closet because it didn't work. I mean, it worked, but you couldn't really see anything fancy with it. It was like, okay, fine, telescope. Went in the closet, and then fast forward to 2016, there's an article in the paper that says, hey, we're offering a class at Sierra College on backyard astronomy. And, okay, signed up for that, and come to find out, I wasn't using it right. And, yes, it is possible to not use a simple telescope right. And once I did, it's like, okay, there's Jupiter, 1, 2, 3, 4 moons. You take your mind goes back 400 years to Galileo, and what am I going to tell the Pope? And it's like, neat stuff. So I went out and I bought a real telescope, because there's only so many things you can see with a 3-inch toy, not a toy, but a 3-inch telescope like that. Got a real one, started using it, and found that it's more of a kit than it is a finished tool. Added stuff to it, upgraded stuff. A lot of it is technique. You don't just simply throw this thing on the porch and see stuff. There's a lot of interesting stuff to it, especially when you look at doing astronomy, photography with it. I was seeing things in the scope. Oh, I could get a picture of that. Show the family, show other people, and so you start adding things on to do the photography, and you come to find out, it doesn't just happen. Part of it is that things in deep space, I mean, you see the stars and stuff, but there's more out there. And a lot of these things are really big and they're really dark. And to complicate things, you're taking pictures, the Earth is spinning. And you don't take pictures of things that are moving. And you look at the pixels on your camera, they're 3.8 microns on the side. Microns are really, really, really small. And all this stuff kind of comes to a head when you're trying to actually play with this thing in real life. And to give you an example, okay, the Earth is spinning. If you're sitting on the equator, you're running 1,000 miles an hour to the east. And which is why whenever they launch satellites, they put the launching thing in Florida so they can get 1,000 miles an hour almost, of head start on getting to orbit. Also, if it goes, bad, it goes splash instead of goes kaboom on someone's house. But that's secondary to, well, primary maybe, to getting the 1,000 miles an hour. So you're trying to focus and aim this camera at something that's moving in the sky. A pixel on your camera is about the size of someone holding a coin 2 miles away. Now, I don't know about you, but I can't even see the person 2 miles away, let alone the coin. But that's what you got to track. And mechanisms are just so good at blindly, they call them clockworks, clicking away. So what you do is you add a guider. And my cursor, the second little scope on the side here, that's not just for fun or for looking through. There's a camera at the bottom end of this thing, the red thing, which goes to your computer, and it's a program that's watching the sky and seeing, looking at the stars, and in theory they shouldn't move at all if everything was perfect, but they do. And as it's seeing the stars move, it's giving little suggestions to the mount, little nudges, saying, hey, a little more to the left, a little more up, and to keep this thing exactly pointed to where it's supposed to be. And when you start doing this, you start getting pictures of things that that you can see, but wow, the moon is just incredible. You see things like Saturn and the rings. Jupiter, you can count the 4 moons, and the big red spot and stuff. You can see these things that are you've seen them. I mean, look outside at night. Right now, this time of year, this was a couple weeks ago, picture of Venus. All you see is this big bright thing. Turns out it's a half moon because guess what? The sun is down below the horizon, and it's only illuminating half of the planet. So you get to see these things. But this is Ham Radio Club. We're talking, I mean, this is my other hobby, but what does this have to do with ham radio? Well, okay, there are some similarities. Both these hobbies they can be rather expensive. Round numbers, the thing I bought last Christmas, that telescope, my new scope there, is about the same list price as the thing on the right there. I bought the one on the left, not the thing on the right. You can do it for cheaper. I mean, you take your DSLR, you point it at the sky, get it on some of the less expensive, they call them sky trackers. You can get some gorgeous Milky Way shots. Most of it is technique and software. It's not the camera. And so you can do a lot of things with some pretty, mediocre, interesting, off-the-shelf equipment that people do these wonderful shots with. But besides that, what is it's just okay. I'm not talking radio astronomy here. This is backyard astronomy. My yard isn't big enough for the radio telescope. I mean, I wish it was. Maybe some of you guys have a little more acreage than I do. But other than that, well, actually, everything. And let me explain a little bit. You go back to the 18th century. This astronomer, Charles Messier, he had a thing about comets. I mean, he had this. It was a ruin your marriage thing about comets. He was just obsessed with comets. And he was looking through his telescope. This is 100 years after Galileo. And he's looking at these things in the sky. He's trying to find comets. He keeps finding things that aren't comets. Darn it, this is not a comet. He started keeping a catalog. A list of things as a service to others of things that aren't comets. These are things not to waste your time on. And guess what? They are 109 of the most gorgeous, scientifically significant things in the sky. It's like, what's this guy, these things are out there. And they're just not important to him. But remember, so this is basically that what we're looking at in the sky is not what's there. There's more to see than what meets the eyes. Things that we see aren't really what they appear to be, and there's things a little bit beyond our perception that we just can't see them. Remember, back until Christian Huygens in 1659, we never knew Saturn had rings. There was no clue, no understanding. Nobody had any idea. Galileo saw it and thought it was like a lumpy planet. Had kind of a saddle to it. Ate a little too much dinner that night. And it wasn't until 25, 30 years afterwards that come to find out, oh, those are rings. You look in the night sky in the wintertime. Everybody knows the three stars that's Orion's belt, and then down below Orion's belt there's three more stars, and that's Orion's sword. And if you happen to be sitting in the middle of nowhere in the middle of winter and you don't know where you are, you're lost, and you have visions of the Donner Party going through your head, those stars at the bottom on Orion's sword point to the horizon at due south. So a little navigation aid for you. Forget Polaris. That points you to south. Turn around and you're looking north. The middle star in Orion's sword, think your Crocodile Dundee accent. Well, that ain't no star. That's the Orion Nebula. You look through your telescope, and wow. Especially if you get a color camera on it, you see these gorgeous things out there. You look in the summertime, it's almost right up overhead near the star Vega. There's this ring. It's like somebody had a sense of humor. The guy who created the simulation that we're all in had a sense of humor, and he stuck a Cheerio on the cosmic background. And what it is, there's a little dim star in the middle of that. 1,600 years ago, King Arthur's tromping around the woods. This star collapses and sheds off this smoke ring. It's a cosmic smoke ring that the star in the middle is lighting up. And it's called the Orion Nebula. They take measurements on it. They can see how fast it's expanding and run the clock backwards, get a date on that thing. Things like Okay, Andromeda, I mean, people know Andromeda Galaxy, right? This thing is 6 times bigger than the moon in terms of our field of view. I mean, to us on the ground, you look at the sky, you can kind of see it looks like a fuzzier than maybe normal star, kind of like the Orion did down there. You get a telescope on it. I can't image the thing. It's too big. It's huge. It's 6 times bigger than the moon. Now, Andromeda's aim is heading. This is the big bully of the local group of galaxies. There's about 50 of them, and it's heading for us, the Milky Way. Poor us. Andromeda is heading here. There's another one behind Andromeda, off to the side a little bit. It's the Triangulum Galaxy, M53. If you look keeping track of Messier's catalog, it's heading for us as well. And scientists aren't quite sure if Andromeda is going to hit us first, or if M33 is going to get eaten by Andromeda, and then the combination is going to hit us. In a couple of billion years, it'll be spectacular either way. I've been talking about the Messier Catalog. There's other catalogs. NGC is the new general catalog. Last month, we have a little, on one of the forums I'm on, as a challenge of the month, and this was the challenge last month. A little galaxy far, far away. That's about an hour and a half worth of exposure, by the way. You don't just take a snapshot of these things. You take, this is 100 and, how many was it? 140, I think, ish frames, all stacked together and processed to get that image. It's a pretty small little galaxy. There's thousands of them. Last night, so this month, the challenge is M53. It's a globular cluster. Is a ball of stars. Think those popcorn balls. It's a ball of stars, about 500,000 to 1 million stars in a big clump. They date back to the beginning of the galaxy, and there's a couple of new stars there. The different colored ones, the yellow greenish ones on the outside, are newer ones. This was like half an hour last night with the telescope. Full moon I wasn't expecting to get anything. This was looking good enough that I thought I'd throw this into the pitch today. First test image. I'm going to get a lot more time on it and refine the image. But it's going to be a really spectacular. M13, if you ever have a chance to look in the summer sky, it's up there along with the Ring Nebula, a little bit off to the side. And it's gorgeous. It's a fantastically gorgeous thing. About 1 million stars in that one. And just a great target to look at. And then just to kind of give you a shot, this is what it would look like last night. I imaged from my neighbor's driveway across the street because I have too many trees. I call it the Oak Nebula across my backyard. And so there's my telescope is aimed up at the sky there. Laptop just watching the electrocardiogram of the guiding as it was going along. Okay, so that's the fun of backyard astronomy. That's the magic and stuff. What caused this talk to come into my mind was an email about a month ago. Club member Phil posts this thing on the group, says, "Hey, I'm seeing this squiggle on FL Digi. What is it?" I said, there is so much going on the radio, so much on the bands, so many things that are right in front of us that we don't even know that they're there. And it's just a big mystery. If you don't ask, you don't know. And you think about the electromagnetic spectrum, DC to daylight, right? That's our playground. We from DC and circuits all the way up to doing lasers across the canyon. We get to play in that playground. And there's so much going on there. So what this talk really is not about astronomy. It's about the challenge of ham radio to get out there and participate and do some stuff. Look at the unknown and try to understand, try to participate, or even just experience. When the bands pick up a little bit, get on HF, on 20 meters, 14230, slow scan TV. People exchanging pictures back and forth. Make Dennis's day and try some CW, APRS, packet radio. There's bands that we haven't played with. When the propagation is not in, is a good time to understand what is in, and get to know more about HF propagation. There's a band at 2,200 meters. That's not a typo. That's just above the audio band. Think about using your living room stereo as a power amp. I don't think it could go up quite that high, but it's not that far away. Operate mobile. Do a little bit of soda backpacking. Go up to a peak and make some contacts. Tonight we'll be talking with Jeff about NVIS, another mode. Technologies, the Joe Taylor suite of ways of communicating. We added the digital voice to our repeater. Play with that. Vacuum tubes, old technology, not just new stuff. And it's a hobby to go build things for yourself. We were going to have a whole bunch of events this summer, but when they come back, volunteer. Get involved with using your skills to benefit others, both in terms of surface events, ARIES, even leveraging other hobbies and things that you might get involved with. And, think about a new role. Get involved with nets, make a presentation. Help me out in all this stuff. So let me leave you with a question. What are you going to do? How are you going to get involved? What's your next step in terms of the hobby? And that's my presentation. Any questions?
Anyone have any questions for Greg?
Very interesting.
Thank you.
Very interesting. How much did it cost for your telescope?
So that scope was on sale. The mount and the scope together, the mount, the rotisserie, and the tripod, and the telescope was $1,100. It's a $1,300 thing. It was on sale for $11 or $12, and I added about another almost $1,000 of stuff to it. But you don't need that much. I was going after the small targets. A DSLR and a good lens and a tracker. If you already have the DSLR and a telephoto, you can get a tracker for not that much, a couple $100, and do Milky Way shots. And people are doing these things, and they're getting these gorgeous images of you see them in magazines, and hobbyists are doing them. You can do that yourself. A small telescope and an astro camera will set you back under $500. So it can get in everything from what you already have up to a whole lot more than I can afford.
Okay, any other questions for Greg?
Hey, Greg, I got a question.
Yeah.
Go ahead, Herb.
I have an STR. I have a real nice camera. Interchangeable lenses. What kind of lens would I need to catch like Milky Way shots and stuff like that? So
Milky Way is wide angle kind of deal. So people use everything from almost a fisheye. Depends on what kind of effect you want to do. Your 50mm kit lens. The scope that I've got there, that telescope's 1,000 millimeters. So think of 1,000mm telephoto lens. That's long. Most astrophotography is done between about 400 to 500 and about 700. The wider field stuff, you get down in the 100 to 300 range to get some of the wider, the big. Some of these you can't do Andromeda with anything more than about 500 millimeters. It's just too big. So almost anything from fisheye up to the longest telephoto that you probably can't afford either.
Okay.
The key is tracking the Earth and getting a if you want to do deep sky stuff, the dim things is tracking the Earth. The planets are really, really bright. I mean, think about taking a picture of the moon. The moon is a rock sitting in the sun. It could be in your backyard. You expose it the same way.